I'm Aleksandra, data scientist at Headtalks, and recently I visited an art exhibition in Barbican Centre in London. It was about AI more than human. That's the title of the art exhibition. And Barbican itself is a very authentic place with surrounded underground cultures, same as AI nowadays. And they actually have a really cool exhibition full of different machine learning algorithms and AI models. It wasn't only supervised and unsupervised deep learning, it was also strategical reasoning, statistical reasoning, game theory, and reinforcement learning, and they combine it all together. So probably you can, everyone could see how AI can driven different projects or art projects. And it started really nice with Puppy. It's a Sony Robotics. It has several senses. It can hear, it can see you, it can balance, and it also very happy to communicate with people. So it shake hands, it follow you from here to there. You can hold anywhere, and you will see the shiny eyes on the face of this puppy. So I immediately forget that this is a robot. I was completely happy, and I thought that on many Instagram pictures it was this dog and me shining, communicating with this dog. And it dog run with reinforcement learning, so environment, the robot is in environment, and you reward the robot to do right actions, and that's how this dog learned. Another robot was humanoid robot, and it gave me another. It was the only one, the only artwork that really scared me, because it was dancing or orchestrating, does something I didn't understand, and I didn't really understand if I touch it, what will help, what will happen with me, how we will communicate. And I back to this puppy through the dense flow of people heading in one direction. So it made me feel that people are really look like robots when they have the only one goal to go through the room to the end. Another really cool robot was driven by magnetic field. It doesn't have any chip. It has only one magnet, and by manipulating this magnet field, this chip folding, and in the blood flow, it goes to its goal, and it unfolds. It carry the human one, and it does a job. Really cool origami robots. It can unfold, fold. They do also not only little blood robots. They do architecture of the building, so it can dance with the music, or it can do something really cool. Before that, so those examples are driven by AI, but they do its own job, and it doesn't learn in the process. It doesn't create anything. It just creates the experience, really bright emotional experience. And back in time, Alan Turing suggested an experiment that a human play with machine or a human, and the goal was: is it possible to define with whom are you playing right now? With computer, with machine, or with human? And if it wasn't possible, then machine was considered to be thinking and thus intelligent. This experiment is nowadays called Turing test, and it's executed to check chatbots if they actually can perform its job or not. After 5 years after that experiment, in 1955, John McCartney, inventor of the Lisp, American computer scientist, he coined the definition of artificial intelligence. So it's not the new buzzword word. It's just, it started 70 years ago and has a really big path. So back to if art can create something or not. There were several really elegant solutions and elegant artwork, and I will show you them. This one is a tulips, and the artists make 10,000 photos of tulips in different blooming process, and she concisely labeled them all with a current process, and she feed it to supervised learning. So whenever you show the new picture of the tulip, network can tell you what's the process, where is this flower. And then she feed these samples to another two networks that compete with each other and generate another samples, another tulips with same statistical values. We will show the result of this second iteration of networks after the presentation. Another great example of artificial intelligence that can create was DeepMind program that can play Alphago. If you didn't see the movie, I highly suggest to see it. It's named Alphago, and it's about how the team of developers and machine learning engineers created from scratch this game. The complexity of this game is it's not the combinatoric game as a chess, for example. So it's not enough to do a fast search. It has to learn how to play. Humans learn it from school. They start learning at the age of 3 or 5, and they learn the whole life. And this DeepMind AlphaGo machine played with a top Korean AlphaGo player, and the first game it won, the second it lost, and the third one it won again. And the player was overwhelmed with emotions, and he said that it actually has its own style. So it was the first example when machine learning show it's not only can perform the job, but it also has its own style. That's why it's so distinctive, and it's a huge step in machine learning. Another research work, was the fragments. So they have a box, and you can smell the fragrance of the flower. The only trick that this flower no longer exists. It last was grown in 19th century, at the beginning of 19th century. And with machine learning, they unfold a sequence of enzymes to create this fragrance. And well, they still don't know if it smells exactly like it was, but by the old description, they match the smell. And that's great. So if we can reconstruct the smell, can we create a new one? I guess it's possible. If you would like to know how AI do this, I choose one of the architect generative adversity networks that generate all deep fakes, that generates musics, that generates poems, and can generate painting with selected style. So something what now is art of state machine learning. It did you hear any of that works, like deep fakes or generating people faces, and those people have never been existed. It's just a picture of generated by network. So as an input, this generator network, there are two networks. They work with each other, generator and discriminator. So to generator, as an input, we set some noises. And we can't control these noises. So we set the input and it starts producing some images. As a training samples, we feed something what we want to have. For example, Van Gogh pictures or painting. And discriminator aim to give you a probability if it's fake or it's real. And by calculating this probability, it actually detects the features of the training samples that create this training samples, something what is distinguish this examples. And then this discriminator feedback these features to this noise as an input and again to generator. And it goes back and forward until this discriminator can't say if it's fake or real. So it returns real all the time. That's how it works. If you're interested to know more or see more samples, you can click on the links and there are nice articles about all the artworks. And this is a tulip. So these two competing networks generated new samples, and those flowers had never existed, but it was generated with statistical features of input signals, and then completed to the video art project. And I would like to leave you with a thought of the one of the most famous argument about if machine can actually understand or not. So the argument is, imagine someone is in a locked room, and in this room, this someone received the notes in Chinese. It has all the library, it has all the tables, and it has all the knowledge, and it starts to respond in Chinese. Is it someone actually understands the language, or it can just translate the language? So this is the argument how we understand another language, how machine can understand another language, and are we actually different from each other? Whether machine can think or not, it definitely can create, and it's really beautiful. Thanks for attention.